Hey guys, it's Mr. Stewart. I've got my son's doctor's appointment today. So you guys are going to be doing a virtual lab using the Chromebooks. I've got the directions in video here as well as written down in Google Classroom, so you should be able to do it. We are going to turn this in on paper because the way to turn this one in digitally is very time consuming and doesn't always work. So we're going to write these answers and stuff on paper that will be passed out to you or should have already been passed out to you. So there's no excuse for you to be able to do this. One little thing, this website may tell you it's not supposed to work on Chromebooks, but I do know that these activities will work on the Chromebooks. So what you're going to do is you're going to go to this link that I've got posted in this assignment from SAS Curriculum Pathways, and it's going to take you to our lab, and this is a virtual lab in linear motion, the VLab linear motion. And so we're not logged in yet. And so what we're going to do is we're going to go down here, and to view this resource, we have to log in. And so in the big box that says view this resource, click log in. And your login information is Alexander Central. There is no password. And so you go in and log it in, and that's a school-wide user password. And you should get the option to then just click launch resource and go. So once you've launched the resource, you can watch this little video that's going to show up. It's going to tell you a little bit about linear motion and what you're going to do in the lab. Excuse me, I'm tired. And once you're done watching the little video, you can click start, and it's going to take you through, and you're going to see the little applet, the little game here. And so in this activity, you can just close this out. It's just for saving or emailing, and you're just going to write it all down, so you should be fine. So this is the simulation, and on this side is the journal, and you've got a copy of the journal, a paper copy that I've given you. Here it is. You got a paper copy of the journal, so this is where you're going to write everything down. So here's your journal, and this is going to walk you through everything you're going to do. And so it's talking about 3 different types of acceleration: zero acceleration, positive acceleration, and negative acceleration, and the graphs that are involved and things like that. And so what you're going to do is you're going to go through, and this actually tells you exactly what to do in the simulation. So when there's a little light bulb, it's telling you something important. When there's a little mouse, it's telling you something about the simulation. And so and then when there's no other picture, it tells you what to do. And so we've got a first trial. We're going to change our position to 1 meter, our initial position. So move that over to 1 meter. We've got our initial velocity, which is going to be over 2 meters per second. So we'll move that over to 2 meters per second. And our acceleration should be at 0. And so there we go. And then once we've got each of those set, we click go to run the simulation. And we describe what Inga's doing. So she's moving forward until the finish line, and she's moving forward at a constant velocity. You see these 3 graphs. We've got a position versus time graph, a velocity versus time graph, and an acceleration versus time graph. And so as we look through this data, we can see that, hey, there's stuff here. And so you can answer these questions based on the graphs and what we see in this simulation. And then you're going to move on and answer about the next simulation, which is positive acceleration. And so you'll change according to what this is telling you, and you'll set it up and go. So that is the first part. Once you finish those 3 scenarios, we're going to go to match the graphs. And so in this one, we've got graphs that have been given to us instead. And this graph looks a lot like the one we saw first. And so we've got a constant acceleration, or constant acceleration of 0. The acceleration is 0. We've got velocity that's constant, and so we've got this initial velocity that looks like it's about what we had before. So let's try it. We'll set it up with a 1 meter initial position, a 2 meters per second initial velocity, and our initial acceleration is 0. And check that out. We're following the pathway exactly. We match the graphs. And so you want to try to match those graphs for each of the trials and follow the directions that are in the journal The third part is an analysis. You don't actually have to open the analysis in here. You'll have that paper as well given to you. In the analysis, you're going to use this diagram here to answer some questions. And then pictures, and then a conclusion question at the end. So if you have any questions, you can. It should be fairly self-explanatory. Follow everything step by step. Please be nice to the substitute, and if you absolutely can't figure something out, send me a Hangouts message, and I should be able to get it. Have a great day.